show that the statement is true for n equals to k plus 1 there. So for n equals to k plus 1 here. So this is going to give us the sk plus 1 term. So here we're simply, so our goal here is just to show that sk plus 1 is simply equal to sk plus a new term that we're going to add there, which is the ak plus 1 term like this. Okay, so now let's go ahead and prove that. So we're going to get this statement the way it is there. So we have our negative 2 here, plus 2, plus 6, plus all the way up to open brackets 4k minus 6, plus we add a new term now, so it means that we move a term further. So where there's k here, we're going to put k plus 1, so meaning that open brackets 4 k plus 1 minus 6 being equal to 2. So a step further again, that is k plus 1 there, open brackets of k plus 1 minus 2 like this. Okay, so now you notice one thing here, starting from the first term all the way up to the k term, this gives us our sk there. Then this new term that we've added here, this is our ak plus 1 term here, like this. Then this term that we have on the right hand side, this side, this is our sk plus 1. So meaning that here, what we're simply just going to show is this expression that we have there. So we show that sk plus 1 is simply equal to sk plus ak plus 1 there. Okay, so let's go ahead and do that. So meaning that where there's sk here, we're going to get 2k, this expression that we have this side. So here we have 2k open brackets k minus 2 plus, then here we're simply going to have 4k. So 4 multiplied by 1, that's going to be 4 minus 6, that's going to be minus 2 like this here, being equal to, then this side we have we distribute the 2 there, so that's 2k plus 2 with open brackets this side, then the other side we're going to have k minus 1, because 1 minus 2 will give us negative 1 there. So this is what we have here. So now here our goal is we have to show that the left hand side, so we have to show that the left hand side is equal to the right hand side there. So if we're able to show this, then we can just conclude to say that what we have here is true for the statement that we're proving here. So now if we try to say, let's expand what we have this side here, we're simply going to have 2k squared minus 4k plus, in this side here we have 4k minus 2 like this here, being equal to, let's check what we have this side. So 2 times this here, we're going to have 2k there. So we have 2k squared, this multiplied by that, we're going to have negative 2k, so plus 2k there, then this multiplied by this, we're going to have a negative 2 there. So now this is negative 4k and this is positive 4k, so those will simply cancel out. So I'm left with 2k squared here minus 2 this side, being equal to the other side we check. So this is positive 2k and this is negative 2k and positive 2k, so meaning that they will just cancel each other out. So we have our 2k squared minus 2 like this. So now here we've shown to say that the left hand side that we have this side is equal to the right hand side this side. So meaning that here we've shown that. So here we've shown that s subscript k plus ak plus 1 is equal to s k plus 1 like this here. So if this is the case here, then you can just say therefore true for n equals to k plus 1. So if it is true for n equals to k plus 1, then you can just say this implies that. So this implies that the given statement or rather the statement holds under mathematical induction for all positive integers n there. So meaning that this holds for all n there. So you can just put a small statement there, say hence proved, like this here. Okay, let's look at another example then. So let's say we erase everything and we add another example then. Okay, show that or prove by induction that okay, so prove by induction that 1 plus 5, so I have 1 plus 5 plus 9 plus 10 brackets for n minus 3 is equal to n to n minus 1 there. So we need to prove that 1 plus 5 plus 9 plus dot 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 plus 4n minus 3 is equal to n and 2n minus 1 there. So here we just go straight because we've been given what to work with already on the left hand side this side, so there's no need for us to start looking for terms there. So now here we're simply going to say we have y1 on this side, so we say we need to show that. So here we say we need to show that so we need to show that the statement is true for n equals to 1 here. So we're simply just going to get 4n minus 3, we equate it to this side, then we check if what we have on the left hand side will be equal to what we have on the right hand side. Then if that's the case, then we can just conclude to say true for n equals to 1 there. So meaning that there, we're simply going to get our 4n minus 3 equal to n there, to n minus 1 like this here. So now, where there's n, we're going to substitute with 1 there, so simply that's going to be 4 multiplied by 1 minus 3 being equal to 1, open brackets, 2 multiplied by 1 there, minus 1, we close the brackets like this. So that's going to be 4 minus 3 being equal to 1 multiplied by anything, so it's going to be 1 there, so we have 2 minus 1. So here we're going to have 1 being equal to 1 this side. So this simply means that this is true for n equal to 1 like this. Okay, so we go to the second step, which is the inductive hypothesis. So I just say inductive hypothesis there.